Tower of Hanoi. Let's look at the rules of the problem or the game. Here in this game we have 3 towers. Let's call them 1, 2, 3 or source. This is destination and this is a helping tower. The first rule is this tower consists of n disks placed over one another at the source tower. So you will see these disks kept at the source tower. The objective of the game is to move all these disks from the source to destination with the help of this tower. So we need to go from source to destination, all these rings, and we can take the help of this second or the helping tower. Now the first key point, only one disk can be placed at a time. That means one disk can be displaced. That means you can't take just all the 3 disks and keep it there. Only one disk needs to be displaced at a time, and then the largest disk cannot be placed at the smaller disk. That means the smaller disk have to be kept on the larger disk. Okay, these are the rules. Let us look in detail with some example. Here is our towers, and suppose we have one disk. That means n is 1 and represent the number of disks. So here we have this disk. How we can move? We can just simply take this disk and keep it here. So move the disk from 1 to 3, and we have successfully completed or achieved the objective of the game. This is source, destination and help. Now let's look another one. Here are the towers and we have 2 disks this time. That means here. Now you just pause the video and think of how we can move these 2 disks to the destination tower, and you can take this helping tower to achieve the objective. Alright, so 2 disks can be moved. If I take this red one and put it here in the second tower. So what I did, I moved the disk from 1 to 2. I moved the disk from 1 to 2. Then what I can do is I can take this green disk and keep it at third tower. So I move the disk from 1 to 3. So this. Now we can simply take this second disk and keep on third. So move the disk from 2 to 3. And yeah, we are done with the objective of the game. Let's look at another when we have 3 disks. This time we have 3 disks, and how can we take these 3 disks and move it here? So I will say, listen it carefully, I will say that I am going to move 2 disks from 1 to 2. But wait a second, you can't take 2 disks at a time. Yeah, I am not taking 2 disks at a time. I am saying that I am moving 2 disks, but these 2 disks are being covered by this method. So these movement of 2 disks, how we are going to move 2 disks? You see this here. How we are going to move the 2 disks from here. And if you want to see a single disk movement, you go and see here. So I am going to move 2 disks from 1 to 2. How we are going to move? Let's see. I will take the red one and keep it on the third one. Then I will take this green one and will keep it at the second tower. Then I will take this third ring and third disk and I will keep it here at the second. So you see, I successfully moved the 2 disks from 1 to 2. From 1 to 2, I have moved the disk. So here at this we have, this is so acting as a source and this is our destination. Though this is not our objective destination, this is a middle helping tower, but I am saying that for the time being, for these 2 disks, let's say this is the destination, and helping tower we did not use it. Then I can simply move the disk from 1 to 3, this yellow one. Then then comes what? Then we need to again move these two disks from 2 to 3. Remember, this movement of two disks, I am not taking two at a time. I am following this method to move the two disks. Maybe first I will keep this red one over the first tower, then I will put the green one over here, and from the red one which I moved earlier, I will put the red one here. So this is how I am going to do. So I will say I am going to move two disks from 2 to 3. Then now this 2 is what? The helping tower. So this is acting as a source, and 3 is the destination. Right? 3 is the destination. Okay. So let's look for n equal to, yeah, the movement is done, you can see. Now when there was one disk, it took one step, right? It took one step. We moved the disk from 1 to 3, so it took one step. When there was two disks, it took 3 steps. How it took 3 steps? Let's see. Red one was here, so I moved the red one over the second tower, and then that was first step. Then here we were left with green, so green one was put here. That was second step. Now the red one which was kept here, I took it and moved over here. So that was third step, the last step. So it took 3 steps. So, and similarly when there were 3 disks, it took 7 steps. We can devise this, and we can go on by devising this formula when we can say the number of steps it takes is 2 to the power n minus 1, where n is the number of disks. Let us try to analyze further. And since when there were 3 disks, we were looking how to do with 2 disks, and that 2 disk step was further break down how we are going to move the 1 disk. So this is somewhat following a recursion. So let's write a recursive function. I will say that let's void Tower of Hanoi, and I am going to pass a parameter which contains the number of disks, the source, help, and destination. And I will say that we were moving, when there was 3 disks, we were moving n minus 1 disk from source, and this was acting as a destination. Right? This helping tower, we were here, remember? We were here. So this movement of 2 disks was done by this source, and this helping tower was acting as destination. Just keep this in your mind that the helping tower is acting as a destination. So I will say here Tower of Hanoi, and it will take n minus 1. The source will remain source, and the helping tower was acting as a destination tower. So I will write simply destination, and there was no use of helping, so I will just simply write helping here. So, and this is Tower of Hanoi. I am calling this function for movement of 2 disks again, because we know for 3 disks you need to know the 2 disks, and for 2 disks you need to know 1 disk. So this is going to call again itself for 1, and this need to stop when n becomes 0. So I can say if n is greater than 0, then perform this. Then what we are going to do, let's see here, then move the disk from 1 to 3. That was a simple process. So we will, this is source, 1 is source, and the 3 is destination. So we are going to print at this time. So we will say cout source and destination. So basically this tells our first step which we did. This is the step. This line is showing the steps. Then let's go back and see. Then again you move 2 disk, that means n minus 1 disk from 2. So 2 is our help, that means help. Now this help is acting as a source, this is acting as a source, and 3 is our destination. 3 is our destination. So let's write here again Tower of Hanoi, and I will pass n minus 1. And what was our source? Source was our help. So I will write help, and source was our helping tower, right? Source was our helping tower, and 3 was our destination. So in place of help I will write source only, and in place of destination I will write destination, because 3, the destination was same, and it's going to call again. So this is somewhat our recursive function, and let's try to understand how this is going to work. So let us trace the function which we have just devised for n equal to 2 disk. So here is 2 disk, and this is the function which we devised, and these are 3 towers, and these are disks. So we need to move the disk from 1 to 2. So 1, 2, 3. Disk is 2, source, help is, and destination is 3. Now n is greater than 0. Here it is greater than 0. So it will come here and it will do n minus 1, that is n minus 1. 2 minus 1 is 1. Source will is 1. Destination is 3 and help is 2. So now this is going to call again, but let's write this out. This won't be executed. First the execution of this should be completed, then this is going to execute, but we will write at this level. So source is 1, destination is 3, and it is going to call again for n minus 1. So n minus 1, that is 2 minus 1 is 1. Help, at the place of help, so help value is 2, so 2 is written. Source value is 1, so 1 is written, and destination value is 3, 3 is written. Now let's finish off this call. Okay, so the new set are this one. N is 1, source is 1, help is 3, and destination is 2. Now this is greater than 0, it will come here, just delete this. So n minus 1, that means this is 0. What is the value of source? Source value is 1, so 1. And what is the value of destination? Destination value is 2, so 2. And help value is 3, so 3. And let's write these also. Source is 1 and destination value is 2. Destination value is 2 and source value is 1. And similarly, this also we will write. Now, first this execution should be finished. Then it is going to go. So, since n is not greater than 0, n is equal to 0, it is going to terminate and it is going to go back and it is going to print out, see out this line. So movement of 1 to 2 is done. Now it will go and on executing this. It is going to call with this value, but since n is equal to 0, this is not going to go and is going to terminate here. It will go back. Function returns when from where it is called. So it will go back and is going to display this movement of disk 1 to 3. That means this disk was moved 1 to 2. Now this lower disk will be moved from 1 to 3. So this is displayed. Now this will go and will call for these values. Since n is greater than 0, it is going to call with n minus 1. These are source. This is source 2, and then destination value was 3, and destination value was 3, and help value was 1. Help value was 1, so 1. And at this level, source is 2 and destination is 3, so 3. And at this n minus 1, help value is, what is the value of help? Help value is 3 and source is 2 and destination is 1. So this is going to, but first this call has to be made. But since it is 0, it is going to terminate. It will go here and it is going to display cout to 3, that is movement of disk from 2 to 3. That the disk which was kept here will be moved here, and this is going to terminate and everything is going to finish off. So this is what the Tower of Hanoi explanation was. And for you can also trace this which I have traced here. It will give a better understanding how the function is working. And let's code this now. Okay, so let's code this. We will initialize the variable with 0 and is the number of disk, and we will get this number of disk from the user. So this is number of disk, and we need to print the number of steps, so we know it takes 2 to the power n minus 1. So we'll call this power function and power n minus 1 and leave a line. Then we need to call this function Tower of Hanoi, which we just wrote here. So let's just copy this and paste it here, and we'll call it here Tower of Hanoi. We'll pass the number of parameter, then source, help, and destination. PRN. Let's submit this. Tower of Hanoi, and so it is accepted, and you will find the all my solution in the description, so you can always get it from there. Thanks for watching.